And welcome everyone to the MapleSim presentation for automation. I will also be giving just a bit of an overview of MapleSim for anyone who's new, just to get a bit of a primer as you head into the other sessions as well, so that you're a bit more familiar with the software itself. So maybe just an overview of the products that kind of are offered by MapleSoft. So of course, there's MapleSim, which is our system level multi-domain modeling tool. So this is where you're going to be building those models, importing CAD, running simulations. Once you've built your model, then of course you want to maybe do some kind of analysis, some post-processing. And MapleSim actually does connect to Maple. So you can use Maple for some of the built-in apps. So they're kind of pre-designed by our application engineers to really give you a leg up in performing that analysis. But then you can also take control yourself and do your own design space exploration, optimizations, and take advantage of any of the packages that are already in Maple that you might be familiar with. Once you've gone through and done some analyses, then of course you want to export your model. And I mean, that's kind of the theme of this webinar is really for automation. You want to be able to export things. So you want to take your model, either you're going to package it up as a C code or an FMU. There are some other options. We're going to look at them today. And the one we're really going to focus on is kind of the FMU and the C code. And so this is kind of the complete cycle where you start with an idea, maybe in the modeling simulation, analysis, and then export. And then of course, as you want to modify, maybe you've exported your model, ran it on your physical system, or compared it to some physical results. Then you can go back to your modeling, do some updates, and continue the cycle. So that's kind of just the overview of the kind of MapleSoft products. And the workflow that we're really focusing on today is maybe I have some kind of initial idea, maybe some CAD that I've already designed in, let's say, SolidWorks, or maybe a mixture of not just a CAD, but also I need some other parts. So in this case, maybe some hydraulics. In all three of these cases, the goal is still we're going to build a model in MapleSim. The examples I'm going to use now are really going to focus on this middle one where I have some kind of CAD. It's just a mechanical system. So once I bring in this CAD, I just need to add degrees of freedom. So some joints so I can allow rotation, translation. And that's going to be the model, my kind of example model. So I build my model. And again, just going over that workflow, we have these built-in apps. So equation extraction, 1D motion generation, parameter sweep. I use these to really look at my model. Once everything is okay and I'm happy with it, then that's when we go to that export. So kind of just a more picturesque view of what we were talking about before. And again, we can export C, FMU. We also export to MATLAB Simulink and Automation Studio specifically. Right. So the first step, if I'm taking this example of my pick and place mechanism, is I want to bring in my CAD. So the image that you're seeing here is from our CAD Toolbox. And when we bring this in, the advantage is now when I generate the components, I'm going to have all the mass and inertia effects that are associated with this system. And of course, if you're going to be running or performing a dynamic kinematic analysis, having accurate masses and inertias are really going to give you the correct results. Otherwise, things won't be, they won't be correct. So that's one of the benefits of using the CAD Toolbox. And then the final part is when you run your simulation, you will also be able to get a 3D representation of your system in the kind of results view. So you'll be able to see your system in action moving along. And maybe just to give a right, so here we can see the components that are being generated. Again, this is that same mechanism that was built and kind of shown previously. But this is the workflow with the CAD toolboxes. And what I want to show now is just a little bit of how does it work when you're in MapleSim. So I'm actually going to go into the product. I won't spend too much time there. Again, just enough to give you a bit of a feel for how the user interface works. So let me just quickly jump out. And this is not going to be the most exciting example. We're going to see a lot of those in the actual slides. But here I have a simple, this represents a pendulum. I have a fixed point in space, a revolute to give me 1 degree of rotational freedom, some arm, and some mass. Now, let's say I want to expand this and make this a double pendulum system, something that's not as easy to analyze by hand or with pen and paper. So I can go to my multi-body, right? So I'm going through my libraries here. I can grab another degree of freedom for rotation. So you see I'm dragging and dropping components onto the screen. Same thing, if I want to add a second arm, I drag and drop to the screen, and I can bring another rigid body. And I'm using keyboard shortcuts just to modify the layout, make it a bit prettier. And then to connect the components, I'm just clicking and connecting. So that's really how we build the models in MapleSim, is drag and drop components and then click to connect. When I want to get information on my system, I can attach probes, and then I can specify which quantities I want to measure. So here I'm taking the X and Y coordinates of my pendulum, and I hit the play button to run my simulation. We have many other webinar videos on our YouTube channel where you can see a lot more in detail, kind of all these different aspects. Again, I just want to give a quick sense, right? So I build my model, and now I can see my double pendulum swinging back and forth, and I automatically get these results for the X and Y positions of my two masses because I added those probes. So this 3D view, this is where if you have that CAD model, you will see the 3D representation. So you'll see that actual CAD moving along. And that can be very beneficial if you're trying to look at the results or just try to convince people on your team that, maybe what you've designed does make sense and is valid. So I'm going to jump right back into my presentation now. I'll just skip through this slide here. We've already gone over it. Didn't talk too much about this, but of course there are many libraries in MapleSim. It is also a multi-domain tool, so you can connect more than one of these domains in a single model. So here we're showing multi-body, which is used for kind of our mechanical domain. We also see hydraulics, electrical, pneumatics, and ropes and pulleys. These aren't the only libraries, they're just a sample of some of the ones that we've worked on and that have been recently developed. So once I built my model, and here we can see it in action. So this is what I would see in MapleSim. Again, it has all the mass and inertia properties automatically calculated from the CAD that was brought in. And now I can actually look at the dynamics of my system. So in this case, one of the questions I could answer or I can investigate is, if I want to run my motor, so this arm here, at a given speed, here it's running at a constant cycles per minute, what's the moment that or the torque that I'm gonna need to be able to achieve this? And in addition, at all these other bearings or these rotational joints, what are going to be the forces? These are all things that I can measure in MapleSim. And you can actually see this on the side here. So as my simulation is moving along in time, I have this vertical blue bar that is reporting to me, where I'm at in time, and I can see the value for the forces and the moments. So if you're looking at doing things like motor sizing, or just if you have a specific motor on your system and you want to see maybe how fast could I run it before I hit those upper limits, this is something that you can actually investigate with MapleSim quite easily. Additionally, you can then go into your model and start doing things like adding some friction or damping in the bearings to represent maybe some kind of fatigue, maybe a lossy bearing. And then you can see, how this can help you decide or help you realize if your system is maybe, robust to changes or to failures. Lots of things that you can really analyze once you have your model. In this example, I was given a constant speed to my motor, but of course, maybe you want to design some kind of more elaborate motion. We do have apps for that, as well as many other things. So on the left-hand side, it's an expanded tree of all the apps that are within MapleSim. So I'm showing here from the component creation group, the 1D motion generation. So instead of giving a constant speed or giving just a simple ramp, what I can actually do is I can specify more elaborate and smoother curves. So in this app, I can actually go and say, well, I want to define some kind of signal that goes from 0 to 3, holds that value, and then comes back down to -2. This could be a position, this could be speed, whatever it may be. This is just some kind of signal. And what's nice about this is you can pick different types of curves. So here I picked Bestahorn, which is just going to give me a lot of continuity, a lot of smoothness. So if you're concerned about things like the smoothness of acceleration or jerk, this is a tool that will help you do this. And this is something that we like to show off a lot to our customers, are these pre-built apps. They really help speed things up and really get you going with MapleSim. Another one that's very popular and gets used quite a bit is the parameter sweep. So as the name implies, you have some kind of model and you want to see how changes in one or many parameters is going to affect the results, or just kind of see how your system's going to respond. So in this case, I'm again thinking about that pick and place model, how it's moving, and in reality, it's picking up some mass and placing it somewhere else, and it's running at some speed. Well, some natural questions to ask are, well, what if I want to see a range of speeds and a range of masses, right? So up here in this section in this app, I've chosen two parameters. I've given it a minimum and maximum, the number of data points in between, and I can run the simulation. Now, one thing, and I like showing this in kind of a more a lengthier demo, but once you click that Run Parameter Sweep button, the code actually gets compiled and optimized. And so when you want to run through, say, 100 or 500 simulations, it's very quick. It's on the order of seconds. If your model is a bit more complex, you might be in a minute or so. And of course, depending on how many results you want to investigate, but it's rather quick. It's not the same as hitting that play button in MapleSim each time because you've optimized the code. And I think it's just very neat, all the effort and power that we have between the Maple symbolic engine being able to simplify equations, and then our optimization procedure for generating that optimized and compiled C code. Once I'm gone and I'm done with running those simulations, I can toggle between different views. Here I can see an envelope view, kind of the max and min for the motor torques that are required. I can also generate a 3D graph. So trying to get a sense of how changes in load or CPM is going to affect that maximum absolute torque value. Again, this is the idea of motor sizing, but the idea holds for any application where you just want to tweak parameters and see how it affects the response of something else that you can measure. Now, we've been talking about these kind of pre-designed apps, and a question we often get is, well, what if I want to create my own? Or what if I want to take the parameter sweep result and kind of continue from there? Well, in MapleSim, you can attach a Maple worksheet. So this will be a worksheet that will look exactly like if you had opened it up in Maple. The difference is you'll have this extra piece that's going to show you your model. And this is what's going to allow you to connect between the Maple worksheet and your model. And then you can actually do things programmatically. So things like running a simulation, changing parameters, collecting results, all the things you can do in MapleSim, you can now do programmatically, in addition to having all the packages that you would normally have in Maple for processing. So in this example, I can see my model. I have a button that I've programmed to simulate. I run it, and then I can go to my simulation results section. So I collapse one area, expand another. And here we can see how that, how there's a bit of post-processing. So of course, the results I get from MapleSim anyways, but now what I've added are the minimum, maximum, and RMS values. So just a bit more programming so you can really tailor the analysis to your needs. And the way that this is all achieved is each of these components, these checkboxes, these drop-down menus, the buttons, they're all just programmed in Maple language. So for example, this show RMS toggle, it executes the code that if I right-click and say, show me the code, it pops up this window, and that's where I can program in that Maple programming language. We have many examples of this. Users have really taken this to create these customized analyses, and it proves to be very beneficial, especially for repetitive analyses where you're going to be kind of doing a lot of iterations. Now, I'll take a second just to talk about some other applications so that you believe me that we're not just here to talk about a pick and place model or CAD or something like that. So here we're looking at a multi-domain system. So this is our rotary telehandler example. Again, we have some additional examples of this on our YouTube channel. What's nice about this model, or different, is it is multi-domain. So it does have those mechanical multi-body pieces, but it also has hydraulics, 1D motion, all combined in one model. And you can see this in the upper left-hand picture. The red lines here are hydraulics. I'm connected to a cylinder that is going to give me that 1D motion. And then I'm connected to the multi-body components. I also have a flexible boom with some arrows that are showing the forces. So as this extends and comes back down, you can see kind of how the forces are distributed along the length of this boom. And the control for the tip of this is actually using inverse kinematics that are also implemented through MapleSim. We also have an entire webinar on inverse kinematics. It's very interesting. I believe they might touch on the telehandler, but it's a very fun topic. It's something that we do very well with MapleSim. So if you're in the business of having some kind of end effector and needing to control its position, give us a call. That's something that we do exceptionally well. Another example, this is using the ropes and pulleys library. So here I have 6 ropes all connected to this box. And by pulling and releasing or winding and unwinding at these bottom pulleys, I can control the position of this box and the orientation. Again, this is using inverse kinematics, but what's nice about the ropes and pulleys library is for each of these ropes, you can actually calculate the tension and slippage at the pulleys, so you can see how your system is behaving if you try to maybe move it faster, move it a little bit slower, rotate it. All those movements, you can really look at the behavior of that through MapleSim using those probes. And maybe the last example I'm going to talk about is our injection molding machine. So here we can see this platen moving forward and back. So of course, right now there'd be some plastic being injected. That part is not modeled. Here we're really focusing on this part that moves and kind of how is this hydraulic cylinder performing? That's really what we're interested in. So it moves in real life. This would be creating the mold, opens up, the mold falls to the conveyor belt, and then the process repeats. We do have a case study here, which there were some vibrations in the model. So with MapleSim, we are able to create a digital version of this mechanism, analyze the vibrations that were being experienced, and then the customer can start looking at new control strategies. And this really ties into our whole MapleSim for automation story. So once you create this model, again, we were able to duplicate the vibration. So we knew that the model was a sufficiently accurate representation of the full system, enough that we could investigate the problem of vibrations. And we were able to take this model to automation software, where then the logic, that PLC code, can be tested, modified, maybe new ideas, to see what could we do to improve the response or improve the behavior. So moving forward, I'm going to keep this model in mind just because I think it ties in nicely to this automation story. It also links to our study. So we're going to focus on this injection molding machine. So the idea here now is we're kind of near that end phase of that whole cycle that we were talking about, where I designed the model, I've analyzed it, I'm happy with it, and now I want to export. So again, using these pre-built apps, one of the options I have is just C code generation. So what you see on the screen is just a snapshot of that app, some of the options that are available, but essentially it's going to generate some C code. It doesn't need to connect back to MapleSim to run the simulation. The solver is actually embedded within the C code. Of course, you can compile this to a DLL if that's a preferred approach. But this is one option, kind of just some C code. A more specific one is if you're looking at Simulink S-Function, we have an app that will also generate a MATLAB C function code and a .m block script, and it'll just then create the block for you in Simulink. In this case, it does use the Simulink solver, small distinction between some of the other export options. But this does exist. And then probably what's more interesting for the automation space is working with these FMUs. And you'll note at the top that I write with or without Insight data. So Insight is another product that we offer, which is specific for visualizing CAD data or 3D data in an FMU. So again, just like all the other options for export, we go to the app, and again, you'll see this option for include MapleSim Insight data. And I'm going to explain with an example exactly what does that mean. But essentially, this app creates an FMU, and as long as the other software that is trying to load the model supports the FMI standard, it will be able to bring in this FMU. So if you're a Rockwell user, so Studio 5000, Beckhoff, TwinCAD, Maple as well can actually connect to these. MATLAB Simulink will also connect. Automation Studio as well, but we do have a separate app for that. So I will circle back to that. But for this FMU, if I have Insight data, what this means is that once I connect to my PLC code or my program, then what I'm going to be able to see is actually a 3D representation of my system. So what we see on the screen here is I'm actually working in Logix Designer, so I'm in that Rockwell space. I've connected my program up to the FMU, and as soon as I start the FMU, I can see it being displayed in MapleSim Insight. And that's what that toggle was in that app. What's nice here is you get a visual cue for debugging. So here I'm changing, one of my control parameters. I'm changing the gain, my proportional gain, and I can go back to my MapleSim Insight, and I can see how my results are changing, both from a 3D view and also from essentially a trace of the outputs. So I can see as I tweak values, am I improving the response or am I making it worse? These are all things that you can investigate. And again, having that 3D representation, nothing beats that. It really helps you see if things are going, as you had imagined in your mind. Now, the last option for export is also an FMU, but it is specific for Automation Studio. So it has this is the same idea as the other FMU generation. The difference is that in this case, the FMU is set up in such a way that Automation Studio will read it without any issues, and will also allow you to see the results in Scene Viewer. Essentially, this means if you're connecting to Automation Studio, you don't need MapleSim Insight because essentially the visualization is taken care by Scene Viewer. And so that's one of the reasons why we have a slightly different export, among other reasons, in terms of importing the code. But again, it's the same idea here. So we can see Automation Studio running. I can see the values essentially in my watch window, but then I can see that 3D representation in Scene Viewer. So these are kind of the different export options. So the C code, the S-Function, FMU also could be connecting to MapleSim Insight, and then the FMU specifically for Automation Studio. So just to summarize everything that we looked at today, we can essentially build a model of your machine in MapleSim. So take your CAD, bring it in. It can also just be an initial idea. It could also be CAD connecting to other domains. It doesn't have to just be mechanical in a sense. You can analyze the dynamics of your machine. And of course, it's multi-domain, so you can bring different domains into a single model. You don't need to have everything separated. Once you've gone through that and you're happy with your model, you can then export it and deploy it to your automation tool, whatever that may be. So now you can test your control code before installing it on the actual machine. Again, that idea of, well, we can try new ideas, play around with values before actually just deploying everything, which is always an advantage. And this can always cut down on costs by using simulation to identify issues before commissioning.